And welcome to session 2 of STEM for first grade. This is Badri again, and we're going to say hello from the other side today, hopefully with a bridge in the middle. And just to remind everybody, we're going to review the story. We're going to discuss what the challenge is. There is an accompanying video that you may want to see that describes 2 bridges we're going to have the kids do. The kits contain the materials to do the bridge. We're then going to discuss the results and go on after there. You may remember this is Javier. Javier is in Texas. He's got a kid that trips and falls into a stream. He comes home. He wants to solve the problem. He researches bridges, recruits neighbors, looks at pictures of bridges, and he goes back and builds a bridge, has a picnic, happy birthday, life is wonderful. So then the question is, how did Javier do it? He applied the engineering design process and he started thinking about forces. And just this picture alone would convey a lot. And you want to say, hey, what is a force? What is pushing? What is pulling here? And the kids may say, well, the kid is pushing on the bench, which is true. However, there is something else pushing against the kid. And if you really start looking at it from classic physics, the weight of the kid is pushing downwards. But there is a famous man called Newton who said every action has an equal and opposite reaction. And therefore, the bench is pushing back against the kid. Then the question is, what happens if the bench is not able to push back against the kid? Then the kid will fall down towards the earth until the earth pushes back against the kid. And in essence, that means if the kid sat on a paper bridge, the paper bridge may not be able to give an equal force to keep the kid on the bridge, and thus the kid will crash to the earth, and the earth will have to do the work of pushing the kid against itself. And so that's kind of happening in this case. And there is a third force as well. The kid and the bench together are pushing towards the earth, and the earth is saying, I am going to push up against both of you to keep you where you are. Another way to think about it, if the kid and the bench are in a pond of water, then the force of the kid and the wooden bridge, at least in this angle, would not be sufficient enough to keep the kid floating the way he is, and so the kid would plunge into the water and probably emerge upside down. So the point here again is, for every force, for every action, for every force, there is a counteracting force that props up things the way they are. Otherwise, the world will not be in equilibrium, and you kind of want to talk about that. It may be a little abstract for kids in first grade, but it'll probably get them thinking. Then we're going to go to our challenge. We're going to say, hey, we're going to give you kits for a couple of bridges, and the goal is to carry 12 cars. Now, cars may not be real cars. They are pebbles, marbles, it doesn't matter. And there are 2 bridge designs that we're going to ask them to do. And if you watch the accompanying video, you will see what the 2 bridge designs are. And the first bridge is going to be pretty simple. It's going to look something like that. And the cars are little marbles that sit on top, and we're going to show them and say, how many marbles can you make sit there? Can the cars go in 2 lanes, and challenge them around there? And then there is an arch bridge where there is an arch in the middle that supports the weight. That will give kids the idea of how to do that. There is also a second kind of bridge where it looks more like the San Francisco Golden Gate Bridge. And if you watch the video, you will see how that is to be done, and we'll try and blow some wind at it to see how it resists wind shear and stuff like that. And just building these 2 or 3 bridges will probably take the better part of an hour. So you really don't want to dwell on the PowerPoint. You want to keep moving fast and get the kids to the experiment part. And once they are done, we're going to stop, bring all the kids together in groups. You would have divided the kids in class into 3 or 4 groups. You would say, group 1, did you build all 3 bridges? How did that work? Where were your forces? Did you get a lot of cars? Was it tough? Was it easy? Did you have fun? And at the end of the day, go home and ask your parents about famous bridges that they saw. And in the picture here, there is a picture of a covered bridge. Perhaps you can end with the question, why do we need to cover the bridge? And somebody is going to say, so it doesn't snow. Well, it's already snowing on the car, and as you very well know, the reason you cover bridges, and there are many of these in Vermont, New Hampshire, those parts of the country, is in the olden days, the bridge used to be built of material that would freeze very quickly, and covering the bridge, reduces the chance that there would be snow on the bridge, but more importantly, it keeps ice out of the bridge, and it also serves as a way to keep the bridge warmer than the surrounding area. So, it helps passage and protects a very important way to get from one part of the town to the other. Thank you so much for volunteering in STEM, and have a good day. Bye-bye.